Hey guys, what's up everyone? How are you people doing? Hoping that all of you guys are doing good and taking very good care of yourself. Welcome back to today's session, guys. My name is Anoop and this is Vedantu. Alright, so people, today is going to be the fourth session of CBSE 10th wherein we'll be talking about resistance in series. In the last couple of sessions, we had talked about current and voltage and Ohm's law and the resistance, factors affecting resistance as well. Today we'll be talking about resistance in series. So before we get started, as always, we'll start off with the quote for today. And the quote for today is this, guys. The expert in anything was once a beginner. And that statement is very true. No matter who you think is your idol it could be Cristiano Ronaldo, Messi, or even Sachin Tendulkar, whoever it is. I'm just taking sports personalities, but whoever you think is your, mentor, or you think that is your inspiration, they were all beginners at one point of time, but then they work their way through, put in the effort, and then they become the experts of their field. So never shy away from giving your best. All the best for your futures as well, guys. So do well and give your 100%. That's all. Anyways, with that said, people, these are the topics that we have covered in the past: current and potential difference, Ohm's law and resistance, and factors affecting resistance. Today we'll be talking about resistance in series. So without any further ado, let us get started. All right, now. Before we get started, there's one thing that I want to remind you of. In the last session, I had given you a homework. First of all, thank you for such an overwhelming response. Thank you for all the answers that you put it down in the comment section below. So here, the question was this: calculate the resistance of 1 kilometer long copper wire of radius 1 millimeter if the resistivity of the copper is 1.72 into 10 to the power of 8 ohm meter. So you're supposed to find out the resistance in this situation. So if you guys remember the formula, I told you that resistance is equal to resistivity of the material divided into the length of the material divided by the area. So that is the formula. So if you just put in the values, you would get the answer for this question directly. It's direct substitution. Just a couple of tweaks you have to do, because they've given you all of that in different units. So convert all of them to meter first. So length, I'll take it as 1000 meters, and they've given the radius, so r is equal to 1 millimeter. So to convert that into meter, it will be 0.001 meter divided by 1000. I'll get it as 0.001 meter. And then if I have to, so they've given the radius. Now I have to find out the cross-sectional area. So to find out the cross-sectional area, you have to substitute the value over there. That is the formula is the formula for radius, or the formula for area is pi r square. So if you put in the values over there, so pi is 3.141 into radius is 0.001 the whole square, you would get the answer. As simple as that. So the calculation might be a little complicated, but then it's actually pretty simple. So if you do it, it'll be 1.72 into 10 to the power of minus 8 into the length is 1000 whole divided by 3.141 into 0.001 the whole square. So if you calculate it, guys, you'll get the answer to be 5.47 ohms, or you'll get it as 5.5 ohms. If you want to round it off, that would be the answer for this question. Hats off once again. These are a couple of names who gave the right answer. Hats off, guys. You have Amaya, Gautam, and Kavya. Wonderfully done. And we also have Stella, Sabu, Manideep, and Avanik. Congratulations, guys. Well done, guys. Well done. You guys were the fastest of the fastest. Hats off. Keep doing this. Keep being more, be more active. And try to put on your answers in the comment section below as soon as the video is out. So yeah, with that said, guys, let us get started with today's session. So let us start off this session with a very simple application based question. If you've ever seen an adapter before, you've probably noticed there are some numbers put on it: 100 to 240 volt or 1.5 amperes. They've given such certain numbers. Below also they've given it as 19 volt and 3 amperes max. Now, what exactly do these numbers represent? See, guys, in an adapter, these number represents the input voltage and current, as well as the output voltage and current. So in your house, you have sockets everywhere, right? So we have about 230 volt voltage basically coming inside our house. Now, a particular circuit, like let's say my phone, it cannot work at that high voltage. It basically would start burning up. The internal circuit that are there would start, we'll have short circuits and it'll basically burn up. So to avoid all of that, there's a safe current that it can work at. So I have to make sure that the circuits are working safely at that lower voltage and lower current. So the whole point of having an adapter is to basically reduce the current as well as voltage, so that the equipment that you're using is working safely under that particular guided value. Now, the question that we're going to answer today is, how do we achieve it? How do I reduce the current and voltage in a particular circuit? So let's talk about that, guys. Now, let us start with a very simple example. Imagine there's a very simple, circuit. Now, if I want to reduce the current and voltage, what I can do is basically increase the resistance. If I were to increase the resistance, the current as well as the voltage would definitely reduce. Now, if you remember the formula, that is Ohm's law, V is equal to I into R. So if I increase the resistance of that particular circuit, the current flowing through the circuit would also reduce. No matter how much the voltage is, the current flowing through the circuit would reduce if in case I were to increase the resistance of that particular circuit. So we can achieve it in different ways. But what I'm going to talk about is one of the most simplest way to achieve that, and that is by a series connection. Let's say there's a simple circuit like this, guys. So there are two resistors. So those things that you see, these are the resistors R1 and R2. There is one separate resistor. There's another resistor R1 and R2, and they're just connected to a battery, which means that there's a potential difference created, and the current is also flowing, which is represented by this arrow mark. So the current is flowing from the positive terminal to the negative terminal. Current flow is happening, and there are two resistors connected. Now, let's say that the current flowing through the circuit is I. All right. And the voltage or the potential difference created is V, or the voltage is V. All right. So I took the potential difference or the voltage to be V, and also the current to be I, and resistors are R1 and R2. So the current is passing through this particular circuit. It will pass through R1, and then it will pass through R2, and then it will come out of it and reach the battery again. Now, let's say that the current passing through R1 is I1. I'm just going to assume it as I1. And the current passing through R2, I'll take it as I2. The current passing through R1 is I1, and the current passing through R2 is I2. I'm just going to assume that it's I1 and R2. I2, simple as that. All right. Now, here's the thing, guys. In a series connection, the current passing through the circuit would be the same. It will not change at all. So what I can do is that I can write that current passing through R1 is equal to current passing through R2, which in turn is equal to the current passing through the circuit, which I can write as I is equal to I1 is equal to I2, because the current passing through the conductor is the same. In a series connection, the current is not changing. At every point that I check, the current would be the same. So I can write that I is equal to I1 plus I2. Simple as that. Now, here's where it gets a little complicated. What I'm going to do is that I'm going to try to find out what is the potential difference across these two resistors. So I'm going to find out what is the voltage across these 2 points, or you can say that what is the potential difference across these 2 points. So first thing first, I'm going to find out what is the potential or voltage across R1. So I'm going to take the voltage to be V1, that is voltage across R1, I'll take it as V1, and the voltage across R2, I'll take it as V2. Simple, V1, V2, I1, I2, that is the current passing through it. The voltage is V1 and V2. Simple as that. Now, to find out what is the voltage across R1, I'll find out what is the potential difference between these 2 points, between A and B. What is the potential difference? That would give me what is V1. So to find out the potential difference across R1, I can write it as potential difference at A and minus the potential difference at B. So I'll take the potential difference at A to be VA, and this I'll take it as VB. Simple as that. So I'll subtract it. I'll get what is the potential difference across R1, which is represented as V1 over here. So V1 is equal to VA minus VB. Simple. I'm finding out what is the potential difference across R1 by finding out what is the potential at this point and what is the potential at this point. So these 2 points, whatever is the potential, I subtract it. I'll find out the potential difference across that particular resistor. The exact same thing I'm going to do for the resistor number 2 as well, that is R2. Exact same thing. So here V2 would be equal to VB minus VC. So if I find out what is the potential difference across those 2 points, if I want to find out what is the potential difference across R2, I have to find out what is the potential at B and the potential at C find out the difference, I'll get what is the potential difference across R2. Simple as that. So what did we see so far? V1 is equal to VA minus VB, and V2 is equal to VB minus VC. Now, in a series circuit, guys, in a series circuit, the potential, the voltage, there'll be a little voltage difference when the current is passing through it. All right, that is one thing that you have to understand, that there's a there's a fluctuation in voltage when the current is passing through a resistor in this case. Now, whatever is the sum of that voltage. So basically, what I'm trying to say is that if I were to add V1 plus V2, I'll find out what is the total potential, or what is the total potential difference or voltage applied across the particular circuit. So what I'm trying to say is that the battery that is there is creating a particular potential difference. So whatever is this value, that is V1 and V2, whatever is the sum of this, that will give me the value of V. It will be the same as V. So the sum of these two would give me the value of V. All right. Now I've already found out that V1 is VA minus VB and V2 is VB minus VC. All right. I'm going to substitute that values over here. So I'll get this as VA minus VB is equal to C. How would I come to that conclusion? So VA is equal to what? VA minus VB, and V2 is what? VB minus VC, right? Across these 2 points, right? So I'll find that out. What will I get? So basically it's VB and VB will get cancelled. So VA minus VC is equal to V. So whatever is the potential difference across these 2 points, it would give me the total potential difference or total voltage applied to the particular circuit. So that is what I'm going to get from this particular equation. Now what I'm going to do is that, what do we see so far? I found out that I is equal to I1 is equal to I2. The current is the same passing through the entire circuit. So I'll take it as I is equal to I1 is equal to I2. And I found out that V is equal to VA minus VC. And I also know that V1 plus V2 is equal to V. So I'm going to keep this as equation number 1 and I'll take this as equation number 2. All right. So I'm going to get equation number 1. This is equation 1. This is equation number 2. Now what I'm going to do is that I'm going to apply Ohm's law. Now what does Ohm's law say? Ohm's law is V is equal to I into R. Now, if you talk about V1, at V1, the current is I1 and the resistance is R1. At V2, what is the current? I2 and the resistance is R2. Simple as that. So I'm going to substitute all that values over here. All right. So instead of V1, I'll put it as I1 and R1, and instead of V2, I'll take it as I2 into R2. And V, I can say this I into R, because that is the total current passing through the circuit into the total resistance of the entire circuit. So I'll take it as I into R. Now, here's the thing, guys. We've already seen that I is equal to I2, I1 is equal to I2 is equal to I. So I'm going to, instead of I1 and I2, I'll substitute I over there. All right. So it'll be what? So this equation will become IR1 plus IR2 is equal to IR. Because I is common, I can remove that aside. So what will I be left with? R1 plus R2 is equal to R. Now, what do I mean by this, guys? The equivalent resistance in a series circuit is basically the sum of the resistance offered by the circuit. So what I'm trying to say is that no matter how many number of resistors are there in that particular circuit, if you find the sum of that, you will find out the equivalent resistance in a series combination. If it's a series combination, if you just add it up, if you just find the sum of it, you will find out what is the equivalent resistance. As simple as that. That's all, guys. All right. So that is what we have seen. So if in case you have, let's say, 3 resistance in the same circuit, then it will be R1 plus R2 plus R3. If you have 4, R1 plus R2 plus R3 plus R4. If in case you have n number of circuit, it will be R1 plus R2 plus R3 in plus the number of times, how many ever the n is. Just put the value of that, you'll find the answer to that. Very, very simple, as simple as that. In series, it's basically the sum of all the resistance offered, as simple as that. So what do we see so far? In series combination, the resistors or the devices are connected one after the other. So it's connected one, that is what meant by series. So one after the other, one after the other, that is what is meant by series. Like a domino, like one after the other, one after the other. That is what is series connection. Secondly, the current remains same. I told you that I1 is equal to I2 is equal to I, because the current is constant throughout the circuit. Secondly, if we talk about it, the voltage, however, gets a little distributed. We saw that the voltage across R1 is different and the voltage across R2 is also different. But then again, the sum of both of these would give you the total voltage applied to the particular circuit. And finally, we also saw that the equivalent resistance is basically the sum of the individual resistance. So that is all about series resistance, guys. Now what we're going to do is basically solve some amazing questions. Very interesting questions. Let's do that. So we'll solve some couple of questions. Now again, guys, I want all of you guys to pause the video wherever you are and make sure to take a pen and paper and be ready with it and try out each and every question and let me know in the comment section below of how you were able to get that particular answer on it. So yes, people, here's the first question on your screens right now. The equivalent resistance in a series circuit if n resistors, each of resistance R is given by what? R equivalent is equal to n plus R equivalent is equal to n minus R equivalent is equal to n into R, or R equivalent is equal to n by R. So they have told you that there are n number of resistors and each of these resistors has a resistance of capital R. So you're supposed to find out what is the equivalent resistance. The answer is quite simple, guys. The answer would be option number C. Without a doubt, it will be option number C. Because why? Because each of them have the same resistance. So whatever the value of the resistance is, that is that into whatever is the number of resistors that are connected. If it's 5 resistors and the resistance is 5, so it will be 5 into 5, that will give you 25 ohms. Simple as that. So it's direct question. So the right answer would be option number C. Very simple. Second question is, now here's another interesting one. What is the equivalent resistance in the following circuit? So R1 is 3 kilo ohms, R2 is 10 kilo ohms, and R3 is 5 kilo ohms. So you're supposed to find out what is the equivalent resistance. Again, it's a straightforward question. So in this case, the options are given: 13 kilo ohms, 15 kilo ohms, 18 kilo ohms, or 8 kilo ohms. What is the equivalent resistance? It's a straightforward question. So R equivalent is basically equal to R1 plus R2 plus R3 because they're all connected in series. So R1 was how much? It was 3, 10, and 5. So it is 3 plus 10 and 5. So that gives me around 18 kilo ohms. So that'll be the answer, guys. Very simple. The right answer is option number C, which is 18 kilo ohms. Now again, guys, I don't want you guys to tell the answer along with me. I want you guys to try out each and every question and let me know what is the answer in the comment section below. Next question. Here we go. There are 3 resistors joined in series in a system having resistance equal to 10 ohms, 20 ohms, and 30 ohms respectively. If the potential difference of the circuit is 340 volt, find the total resistance and the current flowing through the circuit. So you're supposed to find out what is the total resistance as well as current flowing through the circuit. Your options are R is 50 ohms and current is 4 amperes, 40 ohms and 3 amperes, 300 ohms and 2 amperes, or 60 ohms and 4 amperes. It's actually a pretty easy question. So for the first part of the question, I'm going to find out what is the total resistance. So R equivalent is equal to R1 plus R2 plus R3, which is basically 10 plus 20 plus 30. So that's 60 ohms, right? So that'll give me 60 ohms. Now to find out the current passing through the circuit. So voltage is given as 240 volt. And I found the resistance is also 60 ohms. Use Ohm's law, V is equal to I into R, or V is equal to IR. So I have to find out I in this case. So I is equal to V by R, which is 240 divided by 60. 0 gets cancelled. 6, 2 3s are 6, 2 1s are 2, 2 2s are 4, 3 4s are 12. So that'll be 4 ampere. Simple as that. So the answer would be option number D, that is 60 ohms and 4 amperes would be the answer. Straightforward, no? Very simple. I knew it. Next question. Here we go. 2 resistors of resistance 5 ohm and 10 ohm respectively are to be connected to a battery of EMF 66 volt so as to obtain minimum current flow. Calculate the strength of the total current in this case. Is it 1.8 amperes, 0.4 amperes, 4 amperes, or 2 amperes? So there are 2 resistors, one of 5 ohms and the other of 10 ohms. The voltage is also given as 6 volt. Straightforward answer. Again, guys, very simple. So V is equal to I into R. First of all, find out what is the total resistance. So R equivalent is equal to 5 plus 10, that is 15 ohms. And voltage is given as 6. 6 is equal to I into 15. So I is equal to 6 by 15. If you calculate it, you will get the answer to be 0.4 ampere. Very, very straightforward, simple question. So 6 by 15, you'll get the answer to be 0.4 amperes. That's all, guys. That is the answer for this question. Very, very simple, straightforward. There's nothing to think about. It's very simple. Anyways, now that you understood this, guys, so the answer for this question is 0.4 ampere would be the answer. Again, straightforward. I don't think I've made any calculation mistake. Yes. All right. Yeah, people. It is correct. All right. So 6 divided by 15, you'll get a 0.4 amperes. It's A, not delta. Sorry. All right. So that is the answer. Moving on to the last question. Let's take a look at this one as well. So study the following circuit and find the current flowing through the circuit and the potential difference across 10 ohm resistor. So there are two resistors connected one after the other, 10 ohms and 20 ohms, and there's a battery. Let's say that the battery is a 3 volt, guys. So they've not given the value, so we'll take it as 3 volt. It's actually given as 3 volt. We've not mentioned it over here, that's all. So the potential difference that is created, or the voltage, is basically 3 volt. So you're supposed to find out what is the current flowing through the circuit, as well as what is the potential difference across the 10 ohm resistor as well. So let's start with the basic stuff. So these are the options that is given. Current is 0.5 ampere, voltage is 1 volt, 0.25 amperes and 5 volt, 0.1 ampere, 1 volt, or 0.1 ampere and 10 volt. So these are the options. Again, I want you guys to let me know what is the answer, A, B, C, or D. Pause the video and then let me know the answer in the comment section below. But nonetheless, just to give you an idea, first of all, find out the equivalent resistance. So R equivalent is equal to R1 plus R2. So R1 is how much? 10 and 20. So that's 10 plus 20. That gives me 30 ohms to be the equivalent resistance, 30 ohms. So you're supposed to find out what is the current flowing through the circuit. They've given you the voltage also. It's a 3 volt battery. So it's a 3 volt battery. Okay. So voltage is equal to 3 volts. So find out the current. So V is equal to I into R once again. So if you think about it, so you're supposed to find out the current. So V by R is equal to I. So what is it? It is 3 divided by 30. Yes. So 3, 10, 30. So that gives you 0.1 ampere. So that is the answer, guys. So the answer was 0.1 ampere. So it can, okay. So the option, it should be either option number C or option number D. Now to calculate what is the potential difference across 10 ohm resistor. So to calculate that, I'm just going to erase this part out. Okay, sorry about that. Let me just erase this part out and check the answer for this one. One second, guys. Let me erase this out and check now. So you're supposed to find out what is the potential difference across the 10 ohm resistor. So in this case, I'm supposed to find out V. So I'll take it as V1 in this case. So I know that the resistance is given as 10 ohms. The current we've already found, because in a series connection, the current is going to be the same. So I is 0.1 ampere. We have already found that out. So to find out V is equal to I into R. That's basically 0.1 into 10. That gives me 1 volt. Simple. So the potential difference across that 10 ohm resistor would be 1 volt. As simple as that. So the right answer to this question would be option number C, guys, where the current is 0.1 ampere and the voltage is 1 volt. Simple. That's all. Anyways, with that said, guys, here is your homework for today. I want all of you guys to write this question out. What is the maximum resistance which can be made by using by using 5 resistors, each of 1 by 5 ohm? What is the maximum resistance which can be attained by using 5 resistors, each of 1 by 5 ohms? Now I want all of you guys to try out this question and put it down in the comment section as soon as you can. So that's it, guys. Thank you for joining. See you all in the next one. I hope you guys enjoyed today's session. If you did enjoy today's session, do not forget to like, share, and subscribe. People do, and click on that bell button so that you are notified about the sessions, and you can give down the answers as soon as you can as well. If in case you want to reach out to me, you can reach out to me on this email ID, anoop.manoharan@vedantu.com. That's my personal email ID. You can reach out to me on that. Thank you for joining. See you all in the next one. Take care of yourself. Stay safe. Adios, people. Take care. Bye-bye.